So let me quickly summarize what we have done so far. For integration, the first technique is substitution, right? The second technique is to do integration by part. And then we have some strategy to deal with trig function. And in the section 7.3, we want to deal with the radical signs. Sometimes it is x squared plus a squared, or x squared minus a squared, or a squared minus x squared, or etc. We have some strategy to deal with this. Okay, now let us continue doing this guy. Okay, look at the strategy. It is the forms x squared minus a squared, right? So it means that we should define x as a secant theta. Remember, at some point, we need to find we take the inverse function of theta, secant theta, to find the relation between theta and x. And remember, in order to take the inverse function, it should be a one-to-one function. So remember, by convention, somehow the one-to-one function of secant would be the angle of theta from the first quadrant and the third quadrant. Okay, remember that. Now, okay. So from this, as we've done it many times, when we define a new variable, x is a secant theta, we need to find the relation between these two variables, right? We take derivative both sides with respect to theta. And the left-hand side is the derivative of x. The right-hand side, what is it? So a is a number, right? So it doesn't really. Derivative of secant will be, thank you, secant theta and tan theta, right? Very good. So now we know the relation between them. Okay, this is indefinite integral, so we don't have to change the limit. Very good. So now this integral here, and remember a is given, and it is a given number, and a is positive. So therefore, this integral dx here over square root of x squared minus a squared, it becomes, so we replace dx by this term, right? It will be yes. Thank you. And the denominator becomes minus a squared, right? Very good. Thank you, Luke. So then we do like a machine, right? Just apply this formula. Okay, the numerator is okay, and the denominator, what should we do with this? Yeah, we factor it out, factor a squared out. Okay, the numerator, we just rewrite it. And here, if we factor a square out, secant square minus, it becomes secant square theta minus 1, right? And what is it? This guy. Yes, right, use that relation. And it will be integral of a secant theta, tan theta, d theta. And here, a is a positive number, so we can take it out of the square radical sign. And square root of 10 square give us 10 theta. And remember, there's an absolute sign here. Thank you, Myers. Okay. So, are we good here? Say it again, please. A and A cancel, right? And we want to get rid of the absolute signs, right? And remember, because here, this theta is from the first and the third quadrant. If you don't remember, let us do it together. Okay? Here. Okay, review. This is the cosine axis, right? And here is the sine axis here. And remember, any angle theta here, tangent of this guy, it will be sine over cosine, right? And sine is nothing else but this distance. Right? This is sine theta. Do you agree? And cosine of theta is the distance from, we project this angle theta here, and this is cosine theta, right? Therefore, look at these two triangles. The red, the small triangle right here, the red and purple. Let me define some point here. Let us call it this point A, this point B, and the red line here cut at the point, let us call it P. Okay. And right here at 1, let us call it M, this point. We see that the triangle AOB is similar to the triangle. This is O. POM. Do you agree? They have the same, they are all right angles, triangle, and the same angle theta, so they are similar. They're similar, therefore, the ratio, the tan theta, which is sine theta over cosine theta, is the same as AB sine of theta over cosine theta will be AB over OB, right? And because these two triangles are similar, therefore, AB over OB will be the same as PM over OM. And OM is the radius here, which is 1. So from this, so we know that So tan of theta will be exactly this value, the distance from P to N, right? So therefore, you can imagine this way. The tan theta is this axis. For any given angle here, you connect from the center to that angle, and wherever it cut the tan axis, that is the value of tan. Okay? And here, this is the positive direction. Therefore, in the first quadrant here, and the third quadrant, we connect any angle here, it will cut the tan axis in the positive direction, right? So tan is positive in the first and the third quadrant. Similarly, tan will be negative if the angle is in the second or the fourth quadrant. Okay? I hope it reminds you some knowledge about trigonometry. So anyway, now let us continue. Okay? And it is very beautiful that the angle is here is from the first and the third quadrant. So tan is positive. Therefore, we can get rid of the absolute sign, right? So we can get rid of the absolute sign. This guy becomes A and A cancel. Here it will be, yeah, secant theta, tan theta, d theta divided by tan theta, okay? So and tan will be cancelled, right? It will be integral of secant theta, d theta. Do you agree? Then what is the antiderivative of secant theta? Yes, natural log of secant theta plus tan theta. We've done that before, right? Plus c, where c is a constant. Okay. Natural log of secant theta, tan theta. You write log in. And remember, there's an absolute sign here. Remember. Okay. Does it for this problem. Okay. But are we done? No, we're not done yet. We found a solution in terms of theta. What we need to answer is to find a function in terms of x here, right? Very good. And as we define, x equal to a times secant, okay? Now let us write it down here. X is a secant theta. Suppose the triangle is like this. Okay. A, B, C, for example, like this. This is the angle theta. So what if this is x? Then what is the length of the from A to B? A, yes. You agree? Because secant theta, from this we know that secant theta is x over A, right? Therefore, if we're given two sides of a right triangle, what is the length of BC here? Very good. So, okay, now to answer the question here, sine theta plus tan theta. Let us, secant theta. Secant theta is x over A, right? And tan of theta will be from this figure. Thank you, Waleed. Okay. Is that clear? So then what we need to do is to substitute the value here, right? It would be natural log of secant theta, which is x over a. And here tan theta will be square root of x squared minus a squared divided by a, okay, over c, and this, and plus c, okay? In the test, you should write these things clearly. You should write the triangle this so that I know that you understand and you did it yourself. Okay. Can we simplify it, this guy? How can we do it? Okay. If we put it all over a, it will be x plus all over a. Okay, very good. And what else? C is a constant. So this is the plus sign. Okay. Say it again, please. I don't get it. Oh, C in R. Oh, I'm sorry. Okay, very good. Thank you. Okay, yeah, you're right. C is in R. Thank you. That is a better writing. Should write it explicitly here. And here, the properties of natural log function put to the power of e, or yeah, not really, but remember, log say it again, please. Yes, is even better, right? Yeah, it's still in the absolute sign, but plus C, where C is in R. Yeah, we used the formula natural log of A minus natural log of B would be natural log of A over B. Okay. Natural log of A plus natural log of B would be natural log of A times B. And in this situation, A is a positive number, so it's fine. We can get rid of the absolute sign, right? So yeah, that's it. Okay, go ahead. Is there any question about this? You don't have to. In the test, you can stop here. It would be fine. Because the meaning of the test is to test your understanding. So if you go to this point, that is very good already. Okay? You don't have to simplify your answers. I am fine with that. But in the future, you should simplify it if you do some work and show someone else. Okay? Any more questions? If not, then we can continue to do another one. Okay? Suppose we need to solve something like this. It looks ugly, right? There are some fractions here and radical signs. but the radical sign is hidden. It is written this way, trick us this way. So, and remember, these terms can be written as this guy. Okay. Now, so this guy, the things under the radical signs here look similar to what we have done, right? So our job is to define. So look at the strategy. What should we define? And tell me. Look back the notes I gave you. The strategy tell us that it is something square plus something square, right? See here, 93 squared. Okay, we need to somehow write it. If we don't know what we should define, let us call it x should be a number multiplied with, what should we define for the x here? Sine or cosine or something? Tangent? If you do tangent, yes, it's also okay, because at the end it will be tangent. Okay, let's try. If we do tangent theta here, right, then we need to find for x squared, right? Therefore, x squared will be a square tangent theta square. And here, what is 4 times of x squared? It will be this much, right? And there, yeah, this is so. And in the end, we want for x squared plus 9, which is 4 times a squared times tangent square theta plus 9. And yeah, the target is to define a such that 4a squared should be 9, so that we can factor it out, right? So such that 4a squared is 9, so that we can factor it out. So from this, we want for a squared is equal to 9. So what should we do? Then a squared should be 9 over 4. Therefore, a will be, yes, 9 over 4. And square root of 9 over 4 should be plus and minus, what is it? Yeah, 3/2. But we pick only one thing. We pick a positive number, so it makes our life easier, right? So now this is a draft. We know that we need to define, so we define x to be 3/2 tan theta. Okay. So what should we do? The same story, right? We need to find the relation between theta and x. Thank you, Logan. So, look. Okay. Now we need to find dx over d theta, right? will be what is it? And yes, secant square. Derivative of tan theta give us secant square theta. Therefore, we multiply both sides with dx here. You can imagine that way. Dx will be 3/2 secant square theta d theta. Okay, very beautiful. So that's that. Therefore, let us write this formula, this integral. Oh, wait a second. Before, oops. Okay. Here is the definite integral, right? What should we do? Yes, change the limit. In terms of x, it runs from 3 square root of 3 over 2, 0 of, it was 10 x cubed, right? Bless you. Okay, now just a reminder right here. Now let us change the limit. Okay, at the point x is equal to theta, right? We have the relation we defined here. Okay, at a point x is equal to 0, bless you. Then we have the relation here. Then it would be, we have 0 would be 3/2 tan theta, right? So we need to find the limit in terms of theta. So what should we do here? Yeah, multiply both sides by 2/3, and the left-hand side is still 0, right? And the right-hand side becomes tan theta. Okay. Then what should we do here? Yes, tan inverse of 0. And the right-hand side is tan inverse of tan theta, which is nothing else but theta. So what is tan inverse of 0? 0. Yes. Thank you. Who was that? Thank you, Kempton. So therefore, theta will be 0. Very good. That is the lower limit. Okay. Thank you, Logan. And we need to find the upper limit at x is equal to 3 square root of 3 over 2. Therefore, we have the relation 3 square root of 3 over 2 should be 3 over 2 tan theta. Okay. Therefore, what should we do here? Yes, and therefore square root of 3 is tan theta here, right? Okay, what is square root of 3 here? Let us say it again. Pi over 3. Okay, yeah, let us review the special triangle, okay? If suppose this triangle ABC, AB equal to AC and equal to BC, then each of them here will be pi over 3, right? Total angles of them, the three angles will be the same. And each of them will be pi over 3. And one more property is that this M will divide BC into two equal parts. So if the unit here, MC is 1, and AB and AC and BC, they are all 2. Okay? Do you remember this triangle? Then what is the length of AM here? Square root of? Yeah, 2 square minus 1 will be square root of 3. Okay? Therefore, from this special triangle, we see that tan of this angle will be, let us say, tan of pi over 3, because they are all pi over 3. This is also 1. So tan of pi over 3 will be, okay? Therefore, from this, we can memorize a lot of formulas. And we can do sine and cosine of some special triangle. This angle is half of pi over 3, which is pi over 6. Again, do the similar things, we can find the tan of pi over 6, and what is it? 1 over square root of 3, or square root of 3 over 3. Right, they're the same. Okay, anyway, this is how you can memorize these special triangles. Go back to our problems here. So go back here, tan inverse of square root of 3 will be pi over 3, right? Okay, are we good? So now we write this integral in terms of the new variables here. Now we write everything in terms of theta. The limit becomes from 0 to 3 square root of 3 over 2. It becomes from 0 to pi over 3. Okay? And x cubed here, which will be x cubed will be 3 half tan theta cubed. Okay? dx here is this guy, 3 halves secant square theta d theta. Okay? The denominator becomes square root of, we know that for x squared plus 9, we do it on top of this. It will be 9 tan squared, right? Plus 9. And they all raised to the 3. Okay? Let's plug into this. Do it slowly. Okay? Then what do we have here? this guy, it will be, this is the product, right? 3/2 cube, it will be 3 cube, 2 cube here, right? There's 2 to the 3. Times 10 cube theta times 3/2 secant square theta d theta. And this guy, we factor 9 out. Inside will be 10 square plus 1, which will be okay? You agree? Then, same story. Secant square 9, we can take it out of the radical signs. It becomes 3 secants absolute signs. And again, it is positive. Therefore, it becomes 3 secant theta, right? But then they are raised to the 3. The numerator becomes here 3, it will be 3/4 to the 4/2 to the 4, right? And here is 10 cube theta times secant square theta d theta. Okay? Yeah, here. 3/2.
Oh,
Yeah. Okay. The numbers we okay. And when you write it slowly, this guy is a fraction, right? It is 3/4 times 10 cubed secant square and divided by 2/4. And then divided by 2, this guy is equal to multiply with a reciprocal. Do it slowly. You see it will be 3/4, 2/4 of 10 cube theta secant square theta d theta. Here, this guy is 3/3 times secant theta to the 3. Okay? A product and then raised to the 3 will be each of them will be raised to the 3. Therefore, yes, we can simplify it. And the numbers here, the numerator cancel with the denominator, which will be 3, 2/4. Oh, yeah, remember we need to write the limit here. Secant square cancel with secant square in the denominator will be okay. So what should we do? Yeah, it's none of the form we have seen in the strategy, right? But tan and secant, we can write it in terms of sine and cosine, right? But if we do it, would it make simpler? Let's try, right? The numerator here becomes sine cube theta divided by cosine cube theta. and d theta here. Okay. If we do this, then what do we have? Okay. Sine cube theta. And the denominator becomes, let us write this slowly. Multiply with the reciprocal of 1 over cosine, right? Okay. So then cosine cancel with cosine. I'll look taller so that. This guy, it will be sine q theta. And here will be cosine square theta d theta, right? What should we do? Say it again. Okay. Thank you. It will be sine square theta, right? Oh, if we do so, okay, if we put yeah, now it go back to sine and cosine. It's not very tricky, right? But if we define u to be cosine theta here, right? Okay, then derivative of this give us sine and d cosine, d theta here. And sine square here, we can write it 1 minus cosine square sine theta d theta divided by cosine square theta. Okay. Then again, it go back to the simpler forms we defined. Yeah, it takes a little more times, but okay. They may have some better ways to do it faster, but this is what we come up with. It's fine. You can just keep doing this. You'll find the solution. Is that okay? Very good. So thank you. Thank you, Audrey. And yeah, thank you, everyone. I will see you tomorrow. Thank you.